This is limiting reactants practice problem number 1, and this is number 1 because it's very similar to the introduction video you just watched a few moments ago. So if you follow along with what you did for that problem, this one should be no problem. This will be a good warm-up for you. So we look at our problem. First of all, the first step is to check the equation is balanced. I have balanced it for you, so you don't need to worry about balancing the equation. Then we look at the actual problem. Given 8 moles nitrogen gas and 12 moles hydrogen gas, how much ammonium will be produced and what is the limiting reactant? So first of all, nitrogen gas right here, hydrogen gas right here, and of course ammonium is our product. So look at our steps. We already did the balanced equation. Step 2, convert given number of moles of each reactant into moles of product. So remember, that means our given number of moles here of each reactant, so 8 moles of nitrogen gas, that's one reactant, and 12 moles of hydrogen gas, that's our second reactant. There's always going to be 2 reactants, so there's always going to be 2 steps you have to do with step 2. 2 times, you're going to have to do dimensional analysis. So we have to convert 8 moles of nitrogen gas into moles of product, which our product, again, is ammonium. How much ammonium will be produced? That is, probably should underline that as well, so you can identify what the product is we are converting to. So let's start off with 8 moles nitrogen gas. We have 8 mole nitrogen gas, and we want to convert that into moles of ammonium is what we are trying to do, moles of ammonium. So 8 moles nitrogen gas. Now how in the world do we convert that to moles of ammonium? Remember, that's where you get the mole ratio. In the mole ratio, you take the coefficients from these elements in the equation and set it up on here. So look at moles of N2. N2 has no coefficient in front of it, so it is going to be 1 mole of nitrogen gas. The next one, we're converting to moles of ammonium. We got that from the problem. You're converting to moles of a product. So that's right here, ammonium. We have 2. There's a 2 right here, so 2 moles of ammonium. 2 moles NH3. We cancel out moles of nitrogen gas, and we're left with moles of ammonium, NH3. Multiply straight across, 8 multiplied by 2 is 16, divided by 1 is 16. So with 8 moles of nitrogen gas, we will produce 16 moles of NH3. That is not our answer. Remember, now we have to do our second product, or second reactant, 12 moles of hydrogen gas. So we'll come down here, do our second dimensional analysis problem. 12 moles of hydrogen gas. Set up dimensional analysis right here. Now remember, the first thing you write down is always what you're given from the problem. The second thing you write down right here, this comes directly from the equation. You are getting that from the coefficients in the equation. That is the mole ratio. So here, 12 moles H2. Now we look to our equation. How many moles of H2 are in my equation? 3. So I put 3 mole H2 right there. And then I'm converting again to ammonium. So that is right here. So it's 2 mole NH3. 2 mole NH3. So we are able to cross off moles of hydrogen gas. And we've converted to moles of NH3. Multiply across 12. Multiplied by 2 is 24. And then 24 divided by 3 is 8. So this will produce 8 moles of NH3. So now my question, which of these is the limiting reactant and how much ammonium will actually be produced? Let's look at our steps. Determine which reactant will make less product. This is how much product will actually be made, and this is your limiting reactant. So which of these two numbers is lower? Of course, it's 8. So 8 moles of NH3, it is the lower number, so that is how much product will actually be made, 8 moles NH3, and that was made from our H2 right here. You got to go back and look at your beginning. That was made from our hydrogen gas. So that means, again, our hydrogen gas, H2, is our limiting reactant because it produced the lower number of product. So that is practice problem number 1.